I've talked a fair bit about this notion of something called the natural ordering of values. So, what exactly do I mean by that? Well, like I've sort of said, it's just the way that we would naturally think about ordering values of some type. So, for example, integers are ordered from least to greatest. So, that means like -3 comes before -2, which comes before 42, which comes before 81, and so on and so forth. Strings, of course, use the lexicographical ordering, and we've already sort of talked about we talked about that in pretty good detail as well. But now I want to discuss this notion of something called a comparator. So when I talked about tree set, tree map, and priority queue, I talked about the fact that we can give a way of comparing things to these data structures, and it will order the elements based on that comparator. So what exactly is a comparator? A comparator is just a way to compare two things. Okay? That's all it is. So where two things can be really anything at all. It doesn't have to be numbers or strings or things to that effect. It can be entire objects. And as we'll see later on in the course, we can compare different classes as a whole, or just completely made up types. We can impose an ordering for them so that if we were to add them to these data structures like a tree set, a tree map, and a priority queue, they will be ordered based on whatever mechanism of ordering we give it. Okay? So the way a comparator works is, let's move over to the IDE and we'll sort of explain it here. We first need to declare it as a type, okay? So we're going to let's create a comparator that will reverse the ordering of two numbers, okay? So the comparator is going to define an ordering of integers such that it will sort them in descending order, okay? So the natural ordering for integers is ascending order, and we saw that if we put integers in a priority queue or a tree set or a tree map, then they will be ordered in ascending order. Though that's not always what we want to do. So for example, we could define a comparator that will sort them in descending order. So let's do that. So we're going to create a comparator over integers, and let's just call it compare descending. That's fine. And now, so let's first import the class. We're going to do new comparator. Now, one thing you're going to note that when you type this out in IntelliJ, you're going to get something that looks like this. You're going to get new comparator of the type and then some braces here. So I would recommend just immediately clicking this. And then you're going to get something that looks like this. So what in the world is going on here? So the way that a comparator works is that it bundles up, so to speak, the mechanism for comparing two things. And the way that it does this is via a method called compare. Okay? And it receives two things of the type that we specify. So in this case, it's going to receive two integers, O1 and O2. And what we need to do is define this method in such a way that it will return an ordering of O1 with respect to O2. Okay? So, but what exactly do we mean by the ordering of O1 with respect to O2? Well, the way that compare works is we return -1 if O1 comes before O2. Okay? We return 1 if O1 comes after O2. And then we return 0 if they are equal. Okay? So it's sort of like compare to for strings. And indeed, the compare to method is actually much more general than just operating over strings. And we'll see that in action. I know I keep sort of saying this, but when we start talking about objects, we really will get into the notion of how to make objects or classes comparable. But for now, what we want to do is bundle up a behavior that will give an ordering such that when we give it to integers, it will return a order that is descending, or that will produce integers in descending order. Okay? So what do I mean by this? So for example, if we were to have the values 42, so let's say we were calling compare. Now note that we are never going to call compare. Okay? That's not our job. What we're going to do is we're going to give this comparator to a tree set, a tree map, or a priority queue, and then while it's doing its ordering of the elements, it will call compare on its own. But I'm just going to show, for the sake of example, what this might look like. Okay? So like I said, we want a comparator that will define a descending order for integers. Okay? So for example, that would mean that if we have 42 and 4, then this should obviously return -1. Why is that? Because we want 42 to come before 4 in a descending order, right? So if we're sorting this in descending order, then we're going to have, like, let's say 42, and then somewhere later we'd have a 4. Okay? So this is just the definition of descending, right? If we had compare of 3 and 33, this would return 1. Because again, we want 3 to come after 33. Alright? And then if we have compare of, let's say, 42, 42, of course this would just return 0. Okay? So let's see what this looks like. So this means that we want to say if O1 is less than O2, then we want to return 1. So if O1 is less than O2, we return 1. And again, the main way this, or the way that this method works is that it defines an ordering of O1 with respect to O2, and that's very, very important to understand. An ordering of O1 with respect to O2. Okay, and I'll emphasize that in lecture, but that's extremely important to understand. Okay, so if O1 is less than O2, then we want to return 1, because that means that O1 should come after O2 if we're doing a descending ordering. Okay, now we can say if O1 is greater than O2, we can return -1, because that means we obviously want O1 to come before O2. Okay, and then otherwise, if they're equal, we just return 0. Okay, so again, this is just the way that compare works, no matter what these types are. Okay, so these could be strings, these could be lists, these could be entire other objects. It doesn't matter. Okay, the thing that we return is generalized. So we always return -1 if O1 comes before O2. We return 1 if O1 comes after O2, and 0 if they're equal. Okay, this is just the ordering that we define, and then we change this with respect to whatever ordering we're creating. Okay, so we've created a comparator. So, and what's nice about the comparator, or at least, or not the comparator, but the way IntelliJ works, is that we can collapse this so we can just hide it for the time being, because it does take up a lot of space. Okay, so what does this override mean? We will talk about that when we talk about objects, so don't worry about it for the time being. Just know that you need to override the, you need to provide an implementation for the public int compare method. And public we don't really care about, the override we don't really care about, and you might wonder why this method is not static, and there's a reason for that, but again, that doesn't really matter for the time being. Okay, so let's create a tree set. So let's create a tree set of, let's just say random integers. So let's create, or let's fill the tree set with, let's say 1,000, or sorry, 100, not 1,000. I can't count, or I can't read rather. With 100 random numbers from 0 to 10,000 exclusive. Okay, so how this, like, I mean, you should know how this works, but all we're doing here is we're filling S with random numbers. Okay, now if we print all of these out, like we've done before, then this should print them in ascending order. Okay, we've kind of seen this with how tree sets work. So now we don't know what these numbers are, but we know that this is going to be in ascending order. Okay, let's do 10 just to make it smaller. Yeah, so we get a list in ascending order. Okay, but how do we tell this tree set, or this can be a tree map or a priority queue, how do we tell it to use our comparator? Well, all we have to do is just pass it like that. And now if we rerun this, we should see numbers in descending order, and indeed we do. Okay, so again, you can pass this, you can do exactly this with a tree map, a tree set, and a priority queue. You can also use this with other data structures that impose an ordering, and you can change the ordering with a comparator. Okay, so one thing I do want to say is that this syntax here is a little cumbersome, and Java 8 introduces a way to make this much simpler, so to speak. And that is with this notion of something called a lambda expression. So you've seen lambdas before. Let's go to, let's see. I actually don't know if I do it with any of these. We've seen lambdas before when we do assert all. Okay? Lambdas are first class functions. Okay? Or they are first class in the sense that lambdas can be used to define anonymous functions. Okay? And you should know what that means from your previous computer science class, because both C200 and C211 and IU both talk about lambdas. Okay? So these are the same thing. We're just not using an explicit lambda keyword. But how exactly does this work? This just says that this comparator is defined as a 2-argument lambda expression that the arguments names are O1 and O2, or the parameters names are O1 and O2, and then the body is defined inside of these braces here. Okay, so we have an arrow that says this is the input, and then this thing is the output. Okay, now we don't actually need to have braces here. Well, I mean, in this case we do, because we have multiple things here, but we could define a lambda expression in one line, but in this case that would be a little clunky to do. But actually, let's see if we can. We can do this with the ternary operator. So for example, we could do O1 is less than O2, then we return 1. Otherwise, O1 is greater than O2, return -1. Otherwise, return 0. So we can do all this in one line. Okay? And even Java is saying, hey, you can just call compare to on this integer object, because integers actually have an inherent way of being compared. Okay? But we don't want to do that. We want to explicitly define how the comparator works, because it's important to know, well, how comparators work. Okay? But in my opinion, doing this in one line is a little more clunky. And also, so getting rid of the, or introducing the lambda expression here gets rid of this override and public int compare. Now, when you're just starting out, I would strongly recommend you not do that, because it's important to know what exactly you're doing here when you're overriding or when you're trying to define a metric of comparison. Okay. Now, as you get better at Java, and as we proceed into problem sets 4 or 5 and the mini project, you can certainly do this, and I would strongly recommend that you do it. But the reason why this is a little harder to read is because now these variables don't have types, or these parameters don't have types on them. Now, they get inferred by this thing, but if this wasn't here, then we would have no way of knowing what these types are. So, in my opinion, it's a little bit more, it is verbose to do it this way, but I think it's easier to read this way. Or at least it's easier to like parse it and understand what it means. Okay? So, in this video we talked about comparators, we talked about how to define a comparator, we talked about how to pass them to things like tree sets, tree maps, priority queues, and we talked about how to use lambda expressions in place of this comparator syntax.